Today we'll start in this module the architecture of the smart grid system. If you could see here that in smart grid system we have 7 sections or 7 parts. The first part is the bulk generation, and the second one is the transmission system, third one distribution, and fourth one the customer. In general, the power is basically generated at the generating station, and these powers basically transformed from the generation station to the customer's end through the transmission distribution networks. And apart from these 4 sections, we have other 3 sections. If you could see here, this markets, operations, and service provider. And coming to the this is the very basic block diagram of smart grid architecture or layout. In this case, I'll start from the bulk generation. And this bulk generation basically generates the power, and these generating stations are basically maybe the coal-based generation, maybe hydro-based generation, and also presently we have renewable sources as far as the smart grid is concerned. In this case also we have wind generation and solar generation systems. And this the major role of this bulk generation system is to generate the electricity in bulk quantities. And after this, the generated electricity or power is transformed to the transmission network and then distribution network and then the customers. If you could see here, the markets, already we have discussed in the first part that this generation, transmission, distribution, and customers are the very, very important part. Along with this, we have this market, operations, and service provider. As far as the service provider are concerned, basically there are certain organizations which basically provide service to the generation system, to the transmission system, to the distribution system, and also to the customers. And apart from that, we have also operations sectors, we have also market. In the market, basically the participants, they basically participate for selling and trading of the power. So we'll discuss slowly one by one every part very quickly. Welcome to the first, the customer domain. In the customer domain, as I said, the customer is the end user part which consumes the power. This is where the electricity is consumed. And if you say these customers are basically of 3 types. The first one is our home customers, that is known as home equipments where we use the power. And second one is the commercial or building consumers, where the power is consumed in the commercial buildings or commercial sectors. And the third one is the industrial power sectors or industrial consumers. If you could see the power range for home type of consumers, the power range is it is less than or equal to 20 kilowatt. And for your commercial buildings, the power range is within 20 to 200 kilowatt. And similarly, for the industrial part, the power range should be greater than or equal to 200 kilowatt. This is basically the energy range. Based on the energy range, we basically classify the customers in this manner. Now, one point here I want to mention, that is the ESI, which is very, very important. That is Energy Services Interface. What is that? It provides this particular system, this particular practice. It provides a secure and interface for the utility to customer interactions. This is a very, very important part of the architecture of the smart grid. Now, if you come, it's a very concise, very important figure, I'll say, where you could see all the customers together. You could see this is the building, commercial part, this is the industrial part, this is the home, and these are all the service operation distribution markets. What I want to say from this particular figure it says that if you could see in every commercial, the customer domain, maybe it is commercial, it may be industrial, or it may be home type of customers. Everywhere the common thing is the metering facility, and we have a basically gateway. You could see here industry also we have 1 meter, and also we have industrial gateway. And similarly for this home type of customers, we have home gateway and also the meters. And as far as the definitions of the smart grid is concerned, the major block of the major part of the smart grid system is the communication system, communication network. A dedicated communication system is very, very essential for flow of the data from one customer end to other customer end, or maybe from one part of the smart grid network to the other part of the smart grid network. Now, as I said, mentioned before 2 slides, that this ESI is the primary service interface to the customer domain. As far as the communication is concerned, for this ESI, this is very important. I just want to mention here, this ESI communicates with the advanced metering infrastructure. This is very important, and this infrastructure, advanced metering infrastructure, is very essential part of the smart grid system. And this is basically interconnected to the ESI. How? So the internet. And another one is also very important part of the ESI communication system. That is, it also communicates with the devices which are present inside the system through the home area network or the local area network, which is known as HAN or LAN. The HAN stands for home area network and the LAN stands for local area network. And coming to the basic block diagram of the customer domain, here it is. So you can see, as I said, we have 3 types of customers broadly, like we have the commercial, industrial, and we have residential customers. And one more thing I have just added here, this is a micro generation. You could see here, this micro generation is nothing. This includes all the type of distributed generations. That is also the part of customer domain. So this distributed generation means we have solar system, we have wind system, we have fuel cells, also we have batteries. So those batteries are also the part of the distributed generations. We'll discuss more about in the subsequent slides or maybe in the subsequent models. And the main role of, as far as the customer domain is concerned, the major part is the building and home automation. We have industrial automation, we have micro generation. And their corresponding functions are defined here in very briefly. If you'll see, what is the function of this building and home automation? The major function of this building and home automation is to control various functions which is happening inside a building of the smart grid. And similarly, coming to the function of industrial automation, it controls the industrial processes, such as, if you see, in all industries we have different types of functions, manufacturing and also warehouses, so many things. And coming to the another domain, this is the second domain I'll talk about, that is the market domain, which is very, very important part again for the smart grid architecture is concerned. And here, as the name suggests, market means where basically where the grid assets are bought or sold. The grid assets are bought and sold. That is the main target of market domain. Now, if you see, there are some high priority challenges. As far as the market domain is concerned, we have high priority challenges. What is the first challenge? The first challenge is extension of price and DER signals to each of the customer subdomains. This is the first high priority challenge. What is that? That means we have 3 types of customers domains. Customer subdomains we have also. Like we have commercial, we have industrial, we have residential customers. So in that case, we have to extend, we have to decide the price and DER signals, it should be properly judged, it should be properly monitored, it should be properly adjusted. And the second one is very, very important also, that is expanding the capabilities of aggregators. I'll discuss more about in the subsequent part of this module. I'll discuss what is aggregators. The aggregators means which helps to participate the DER small utilities to participate in the big markets of the power. So where the power exchange takes place. So in that case, the expanding the capabilities of these aggregators, that is also a very, very important part, function, challenge of the market domain as far as the smart grid is concerned. Now we have interoperability. This is very, very important. Interoperability, this what I'll discuss in detail of my slides, and I just want to say, what is that actually? It means we have many devices, many equipments present as far as the smart grid is concerned. We have generation, we have transmission distribution equipments, we have customer premises, we have different equipments are present in the customer premises. So in that case, we have to, we'll set in such a manner in the smart grid, we have to basically, they should speak to each other. Every device present in the customer domain, devices present in the transmission domain, distribution domain, they should speak to each other. So that is what interoperability. Now, this is how the across all providers and consumers of the market information. What is happening inside the market of the smart grid? The information should flow to every part of the smart grid system. Now, this the fourth one is managing the growth and regulation of retailing and wholesaling of energy. This is also important. This is the one part of the challenging task as far as the market domain is concerned. Now, and the last one is also part of it, that is the communication mechanism for prices and energy characteristics. This is also very, very important. What is this energy characteristic? The energy characteristic is between throughout the markets and customer domains, because the customers are the end user. So there we have to say what should be my energy characteristics, what should be the price of my energy which is going to be sold to the customers. Now I'll just come a very brief diagram, or I can say it as a very basic block diagram of the market domain. You can see here we have the sections of the parts of the market domains. This is the DER aggregation, and this part is market management, and this is the market operation. This is wholesaling, trading, and ancillary services and retailing. So these are the components of the market domain, right? So these components are going to also access our transmission, customers, service provider, generation, distribution operations. As I said, in the smart grid system, all the parts, all the domains are interconnected with each other. That is very, very essential, which will lead to the name of smart grid, which was not available earlier, So that is why this market domain is also linked to each domain of the smart grid system. This is the function of each domain. In short, I'll just discuss that. I'll start from this retailing. Retailing means here in this retailing section of the market domain, we'll sell power to the end consumers. We're selling the power to the end consumers. These consumers will basically consume the power. So this retailing part helps to do that. And also connected to the trading organization. This is also second function of this retailing part or retailing component of the market domain. And the second one is the DER aggregation. Already we have discussed this word. What is aggregation? The aggregation, nothing. The aggregators combine small participants in the market to sell their power to the energy market, to participate in the energy market. That is what the DER aggregation. And next is our trading. In case of trading, we have this, it's a very important part of this market domain where we go for buying and selling of the energy. That is very essential part of our market domain. Now, of course, this market operation is also important. That what is the function of this market operation? The market operation basically function very smoothly, and basically the financial and goods which are used in this smart grid environment. What are the financial documents, financial affairs, or the goods which are sold inside the smart grid environment or system, and also the price quotation streams, edit balancing. So these are all the part of, this is the major part of the market operations. And we have ancillary operation. In the ancillary operation, sometimes also we have to support the frequency and the voltage and the spinning reserve of smart grid system. So this ancillary operations are ready to supply those support. That is the frequency, voltage and spinning reserve support. And coming to this market management, because every system should have some management system. So this market management is also there to manage the ISOs. You could see here this ISO means the independent system operator. This market management block or this component of the market domain helps to manage the ISOs for their wholesale markets. So these are very in brief the functions of the market domain. Then come to the third part of the as far as the architecture of the smart grid is concerned, that is service provider domain. In this case, as the name suggests, service, we have to provide service to all the components, all the sectors, all the things which are involved inside the smart grid environment. That service provider, I'll just define this very short. It supports the business process. The first part, I'll just name it. It supports the business processes of power system producer. The producer means it may be the generation, it may be equipment producer, anybody. So we have to provide, this service provider domain will provide the business processes and distributors and customers. Yes, of course, because as I said, the power network has the basic building blocks, that is the generation, distribution and the customer consumption. That the customer is the last end part of the electric network. So the service provider domain will help in processing the business of these three domains. And coming to another point which is basically involved in the service provider domain, that is the business processes range from traditional utility services. This is important. The traditional utility services such as the billing, and we have customer account management, we have enhanced customer services such as management of use and home energy generation. See, these words are very, very important. Every word has a meaning. Like if you see that, as I said here, the traditional utility services such as billing,